guess get started. This is CSE 519. This is I guess depending on how you count, the third or fourth lecture of the semester. What I'd like to start out with, first of all, are there any questions about anything logistical before I go in? Homework 1, which was simply the video thing, when it should have been gone in. Any questions about that? Or did that go well enough? Okay. As of today, we are passing out homework 2, which is the first real assignment in here, which is going to be we're going to be looking at data from a Kaggle challenge that is related to kind of running a store. And last year in this class, the course project, they were, again, you will be doing graduate projects and there'll be course projects. And one of the course projects from last year was that there was a chain of shopping stores on Long Island that gave us access to all their sales data. And it was very, very interesting to look at, what happens when you look at sales data, are there periodicity effects? Okay, are there, do you sell more Christmas stuff in the winter than in the summer? Okay, you see all kinds of interesting things. And the Kaggle challenge for this that we're going to base the homework 2 on is actually based on kind of essentially a store and that has a bunch of products. And we're going to be trying to predict how much different items will sell in the future. That's kind of what the challenge is about for homework 2. This starts now. I'm going to hope that next time, for next class, I'm going to want everybody to take a look at homework 2, maybe get started on it. And I encourage discussion about the homework in class so that, people can learn from each other about what things are hard or not. But in order to do the homework, any questions about homework 2? This is an individual assignment, so everyone's going to have to do it by themselves. But in order to do it, this is the time when you got to get familiar with Python and start to learn how to program in Python. So at this point, I'd like to have a lecture by some of my graduate students, my PhD students, who are, doing data science and, supposedly do this for a living. So I'd like to introduce 2 of my graduate students. There's Charuta Pethe and, Fahad Sultan. And they're going to give a lecture an introductory lecture on Python based on the results of the poll that they passed out, right? So why don't you start with what the results of the poll were and then go into what your lecture is. And I strongly encourage anybody with questions, to weigh in and yell out, okay, so that this becomes interactive to an extent. First of all, any questions? Okay, so has everybody used Python? The answer seems to be yes. The guy that said no, well, you have to work a little harder. Okay, what did people do? Everybody's run from a terminal. The environments that I guess we're going to learn about today and use are either a Jupyter Notebook or the Google Collab. And this is kind of it's important that we be working in the right environment. And you're going to be showing them what today?
We'll be running a Jupyter Notebook from Google Collab.
Okay, good. Okay, and some fancy little things. Okay, good. What are we familiar with? Okay, it seems that there is some general conception of how you program in this thing, but when you start getting into some of the more complicated features, people are less familiar with. Okay, good. Working with files, okay. Several people have done things, so that's good to know. Okay, which libraries? Again, one thing that is, I guess, important is to know what different libraries there are and available and how to use them. And so that's something that I guess this is going to focus on, okay. particularly some of the data manipulation libraries like Pandas. Okay,
Yep.
very good. Okay, at this point, unless there are any questions, I will propose we turn it over to Charuta. Okay, Charuta, you are on the stage.
Okay. So hi everyone, I'm Charuta. I'm a fourth year PhD student, and so today's lecture is going to be about using Python for data science. Not exactly a Python 101, but we will cover some Python before we get started with any data set. So just to give you a brief overview of the usual steps that you'll end up doing in a data science project, the first step is either collecting data on your own via user studies or web scraping, or getting it from a data source if it's already available. The second step is pre-processing and cleaning up this data and manipulating it to get it into a usable form for the purpose that you need it for. After that, you would run some analysis and predictive models using this data, and finally you would visualize and present your results by means of graphs or whatever analysis you've done. So let's get started with the Python basics. It looks like most of you are familiar with Python, so this is a print function where we're giving this string as an argument and it's simply printing it out to the console. Function definitions are done using the keyword def followed by the function name and the parameters to the function within parentheses. We can do whatever computation we want with these parameters within the function and then return the final results. So in here, since data types are fluid in Python, we can pass either a string or a number as the first argument, and the star operator works as a multiplier for both. Another way to define functions is inline using Lambda functions. Oh, by the way, is my font size okay?
Yeah.
So using Lambda functions, here we're using just a bit of a different syntax. We aren't using the def keyword. And when we define this here, it's the keyword lambda followed by the parameters of the function followed by a colon. And whatever computation we're doing, we can split it over multiple lines, but usually for Lambda functions, it's more convenient if the function is short and we don't need to define it externally. So repeat runtimes and repeat runtimes too are basically defining the same thing, just in two different ways. And we'll also see an example of how to use a Lambda function inline. It's not necessary to assign a name for this whole thing. In this case, we want to call it as repeat runtimes too. But we can also call it directly within the same line. We'll see an example later.
Okay, so just to make sure, first of all, can people understand what she is saying? Are there any questions about? I'm not sure because I'm not sharing the screen. I can't see it. But are there any? Is what she's saying clear enough? Can everybody hear? Or do people want it to be something different? Okay. A bit slower is what I'm hearing. Okay. Any other comments? Okay. So the reason you do the Lambda thing is just so you can define functions without having to give it a name. Is that correct?
Yep, and in some cases, we might be using a function applied to a data set column. In that case, we just want to define that within the same line instead of defining it externally and then having to call it from there.
Okay, so if you're going to use a function just once, basically, in your program, this is a way to define it.
Yep.
Okay. And again, I encourage people to ask if they want things slowed down. Keep going.
Okay. So the next concept is loops. So in this cell, we're using quite a bit of Python concepts in here. So on the first line here, we're defining a list with 3 string elements. This is an awesome. We're assigning it to the variable list sentence. So we have 3 different ways to iterate over this loop here. So in the first way, what we're doing is first we're calling the length function on this list. Then we're calling the range function on this. So this will return 3. And the loop essentially says for index in range 3, which index will have the values 0, 1, and 2 for every iteration of the loop. So once we are inside the loop, this line is accessing the ith or the element at number index within this list, and it's assigning it to the variable word. And we're printing out word plus an exclamation mark concatenated to the end. So this part is the result that we see from the first loop. Any questions about any of these?
Okay, so what I'm understanding this to mean is that range is a function that gives you the numbers 1 to n, right? For index in 1 to n means that it's going through that set. And then for each one of these, or 1 to n minus 1 is what I'm hearing, or maybe 0 to n minus 1, okay? And it is going to then use that as an array index into the what you've got and print the right thing. So I understand what that does. Any other questions about it? And the second is a different way of doing the same thing?
Yep, it's doing the same thing, except instead of using range, we're using the enumerate function, which returns a pair of index as well as elements. So when we iterate, we have the index and word already ready. So we don't need to do this assignment inside of the loop.
Okay.
So this is the output from the second loop. Here we're printing out the index and the word concatenated with 3 stars.
Okay.
So for the first approach, this is useful mainly when we're interested in the index of the loop, or we want to do some extra manipulation with the index. This is when we're interested in both. And if we don't care about the index at all, and we just want to iterate over the elements, we simply use for element in list.
Okay.
Should we move on?
I say yes, unless there's any questions. And don't be afraid to shout out questions, by the way. Keep going.
Just I know there's a
Now, if I didn't know better, I would say that the last of those 3 is the shorter and simpler way to do it. Am I correct?
Yep, that's right. We usually use this a lot when we're not interested in the index.
Okay, fair enough. Go.
So another way of representing loops in a short and concise form is by using list comprehension. Let's say we have a list and we want to extract all the elements that start with the letter A. So the traditional way to do this using loops would be to define another list of its own. Iterate over every element in the original list. If that element starts with A, then we append it to the new list, and then we look at the new list. Does this part look okay?
So this is to pull out the words that start with A.
Yeah.
Okay.
This is we're doing for every element in the original list, checking if it starts with A, and if it does, then we append it to a new list.
Okay. Stupid question. How do you discover that there is a command or built-in thing that does starts with?
Oh, so here, if especially in Collab, if you do, let's say, so when you do x dot, it gives you a list of all possible functions that you can apply to your string.
Okay, that's interesting. Okay. Any questions about that?
Yeah, I just found out that there's a lot of lag in what I can see and what's being shared.
Okay, I see that. Okay, fair enough. Go on.
A quick question.
Great question. Good.
The double quote and the single quote, any difference in Python?
No, in Python, it's both of them are the same. If you're interested in involving any of these characters within your string, so you could define this as either string or as string. And if you're using single quotes, you can add double quotes as a character within your string. So this would be a valid expression. If you wanted to define your string using single quotes plus have a single quote character, it would look like this with a backslash. Yeah, there's quite a lot of lag.
All right, get it.
Stupid question. Do you guys use Python 2 or Python 3?
I mostly use 3. There's not much of a difference except for the print statement needing parentheses in Python 3.
Okay, so there's no real reason to be using Python 2 these days. Is that what you're saying?
Yes.
And Python 2 is dying, right?
Yes, I think they're stopping Python 2 maintenance
Yeah.
sometime soon.
Okay, go on.
Okay, so this was the way to do it using a traditional loop structure. If we use list comprehension, it does basically the same thing. It's just that the code is a lot more concise and we can do the same thing in just one line instead of 5. So what we have here is again the same string containing the same words. And here we have used the loop. What we did using the loop, we're doing in one line by saying, this is essentially saying for every element in this list, if it starts with A, then add it to this new list.
And the new list is also called X? What is the first X for?
So this is a for loop. This is iterating over this, and then for the second one, so for this X, it's equivalent to saying list2.append X. So it's a set of all X for every element in X if the condition is satisfied. I can show you one more example. So it doesn't necessarily have to be the same exact element that we want. So we could also manipulate this and say X plus something and concatenate it. So this is the body of the loop followed by the iterable in the loop. Does that make sense? And then if we wanted, we could assign this to another variable.
Okay, any questions about list comprehensions from people? Like why you would use it or how you would use it? You have another example?
Yep, I do.
Okay.
So here I'm using it on a dictionary. So dictionary is a set of key and value pairs. So here we have where the key is A, the value is 0. For key B, value is 1 and so on. So here the loop is doing, it's iterating over every key and value in this dictionary. And if the value is an odd number, we're appending key and value to this list.
Okay.
It's doing something similar here over all the elements inside a string. So the string says data science, and then we're iterating over every character within the string. And we're adding the character plus an exclamation mark to this list.
Okay, any questions about that?
How do we do multiple append operations with this? Like, let's say I want to append every second value and third value in different lists. So do I have to like assign? So it's basically in one line of code, you can just do one append operation, right?
So you can do nesting within this, but I think if you want to add elements from 2 or 3 different lists to the same one, you'd be better off using.
Okay.
So I guess if you wanted to make like, you had something about odd numbers, if you wanted to have the one, produce lists of the even ones and list of the odd ones, you would recommend doing 2 of those comprehensions rather than trying to interleave them.
Yep. So this is a way of doing it in. Yep. So this is a list comprehension within a list comprehension. So the outer loop here is saying for every string in this list, we want to add this part to our array, the first half part to our array. And then that in turn is operating on every letter within that string. So you can deal with multiple data structures within the same line if you're using list comprehension, but appending things from different data structures to the same one, then loops would be better.
So essentially, whatever is before the for operator is the thing that gets appended, right?
Yeah.
Okay, thank you.
And also you could add another if condition here. So let's say if you don't want the letter to be A. So just removed A from wherever it was present. Let me show you one more example here. So if you want to include an else as well, so let's say if it's an A, you want to append an exclamation mark, otherwise you want to append a question mark. So the syntax is slightly different. If there's only an if, it comes after the for clause. If there's an if else, it comes before the for clause. Does anyone have questions about this nested list comprehension?
Any more questions? If not, move on.
Okay. So within
Sorry. I have a quick question.
Good.
Why would you ever want to use a print if in this Python, it's called a journal or a Jupyter Notebook? Why would you ever use a print statement if you just have an IDE line?
So sorry, is the question if everything is printed anyway, why would you need print?
Yeah, just if you're defining a function, then you immediately call the function, the output is printed out. Why would you ever define a print statement?
If you wanted to print out values that are between the cells, so only the thing that comes in the last line of the cell gets printed out. So here, for example, if I added list 2 and executed this, it wouldn't print out list 2 at all.
Okay.
If we add a print to this, it will print out both of them.
Okay, sure. That makes sense. Thank you.
Any other questions? Okay. So inside of the Python ecosystem, you will end up using a lot of libraries for doing data science work. So the stack is essentially at the base of everything. There is core Python running. IPython is an interactive Python shell. And then the most common libraries that you will be using are Pandas for data manipulation, Matplotlib and Seaborn for visualization, and NumPy for some basic math manipulations, and sklearn for using predictive models of the shell. So today we're going to be doing some demos of mostly Pandas and Matplotlib, maybe a little bit of NumPy as well. And we have a small set of sklearn codes in the end. So to get started, I don't think many of you are familiar with Anaconda. Most of you have run Python from the terminal. So Anaconda is basically a bunch of all of these libraries bundled together, and it contains almost every library that you would need in this course. And it's an easy way to avoid installation and dependency issues amongst libraries. So the installation link is here. We'll share this after the lecture as well. So it's UI based. You would just need to download the installer for your OS and Python version of choice, hopefully Python 3, and you would be ready to go. So a Jupyter Notebook is it's what we're using right now. We're just using it in the collaboratory environment provided by Google. So this presentation itself is a Jupyter Notebook, and you can open it using Anaconda as well. So the difference between that and this is that Collab is a free Jupyter Notebook environment that runs entirely in the cloud. So you wouldn't need to install anything on your local machine for this to be able to run. You would just need to go to the Collab website and you can start running your code right away.
Now, what is the downside to using a Collab? Okay, is there a lack of resources that you get?
Yes, I think there is an upper limit on the amount of cloud resources you can get. Plus, you would need to upload all of your data to the cloud before you'd be able to use it.
Okay, so you're saying that there's a limit to how big a data set you can upload. Is that right?
Yeah.
And I guess the data then becomes somehow visible to Google. So you probably don't want to loan anything classified here. Is this correct?
So for a formal project, it would be more ideal to work in an Anaconda environment.
I think you can use, you can mount Collab notebook into your Google Drive. If you have like university account, then you can access like unlimited drive storage. So that can help you in your project.
Okay, if you want to describe how to do that on Piazza, that might be a helpful thing for people. Okay? But do you recommend that people install Anaconda, or you think that they give up and just do the Collab?
No, it's pretty much hassle-free. I would recommend installing Anaconda.
Okay, so for next class, try to install Anaconda if you don't yet have that on your machine.
There's one caveat with Google Colab. I think that the runtime environment expires after 12 hours.
It expires when?
After 12 hours.
Okay, so you're saying that if I try to tell you you're going to run a big computation, that's not going to work, right?
Yeah, you cannot leave it inactive. And
If a computation is running, I think it should be fine, but we'll have to constantly keep dumping everything to disk, and it
I mean,
won't.
you cannot have it inactive.
Right. Okay, so I think that it's better, ideally, for people to do it on their own machine, but this is for people to figure out.
Oh, can I mention?
Yes.
Oh, I think for a collaborative project, it would be useful to have a shared environment such that all the package versions are exactly the same. Sometimes the package behavior may be different if it's Mac platform versus Windows platform.
So this you're telling me is good if you have several people working together, okay? And that I agree. Homework 2 is done individually. Should several people work together on it? Okay, no. So, but you figure it out, okay? It's good to have access to both. Okay, keep going.
Okay, so next is we're going to play with a data set that we have. So we're going to be manipulating it using Pandas first. So Pandas is a library where you can play around with the rows and columns or do selection of operations as and when you want. And because it's loaded in memory, it's super fast, but that's why it's also not ideal for data sets which are bigger than the memory size of your machine. So the first thing we're doing here is importing the Pandas library as PD. So whenever we're calling a Pandas function, we would say PD dot as we're doing here, and it would invoke that function from the library. So the first function we're using here is read CSV. So for this function, you can specify either a local file path, or in our case, to be able to use our data set here, we've uploaded it to Git, and a URL works for us as well. So let's go ahead and read these two files. And then these are a few common functions that you will be using to figure out what exactly.
Pandas is good for data matrices. Is this correct? The reason you're using Pandas is when you have a data matrix. Is that correct?
Yep, that's right.
Okay, good.
What's the difference between a dot read CSV function and a normal open function? Because CSV is essentially a text file, right? So can we use the dot open function as well?
You could also do this, like if you wanted to port this on your own, you could say open the file and then separate it based on comma and then populate all the fields that you want. This function just does it for you. So inside of this function for its arguments, you could also specify a delimiter in case you have a tab separated file or a file in some other format.
Okay, so this has an advantage when we are dealing with CSV.
Sorry, say that again.
This function is like it's better
Yep,
when you're dealing with a lot of data.
So this attribute, when you say this is the name of a data frame, so when we called the read CSV function, it populated this variable called TED main. So this is a data frame variable. And the first thing we're calling on this is the dot shape operation. So this is telling us the number of rows and columns that are present in this data frame. And then the next function is the head function. So this returns the first, in here we're specifying the parameter as true. So this is returning the first 2 rows inside our data frame. So this lets us look at what exactly the columns that we have are and what kind of values are inside these columns, not for the entire data set, just to get an idea of what the data looks like. So this is a data set of TED Talks, and for columns we have very diverse columns ranging from the number of comments, the description of the talk, the duration. This seems like it could be in seconds, but it will be good to go and double check. The event in which it was filmed, the film date also seems to be in a weird format. We need to pre-process this later. And there's a bunch of other columns like the speaker name, the number of speakers, and the title, the tags, and so on.
Okay, so the names of these columns came from the spreadsheet. Is that correct? The CSV that you loaded, right?
This is the first line of the CSV, yes.
And are you going to be able to manipulate these things by using those names?
Yes, we can.
Okay, so this is what makes it more powerful than just like a matrix. You're not talking about column 17. You can refer to it by name, for example.
Yeah. So that's what we're also doing in the next cell here. So if we want to look at just the ratings column, or let's say just the name column. So each column in this data frame is a series on its own, and when we index it using the column name, it returns a Pandas series object, which is an index and the corresponding value.
Wait, why did it return past the name? Which column is oh, name speaker is what you mean. Name is the name of the talk. Okay, got it.
So one way to access the name column is by doing this, indexing it with the column name using square brackets. Another way is to just say dot followed by the name of the column. So when we say tedmain.url, it also returns a series of the URL column. So after this, 2 other functions to access specific elements of this data frame are lock and ilog. So I'll explain these 2 functions in 2 parallel data sets. So for example, here when we say tedmain.ilog42, this gives us row number 42. Yep, this gives us row number 42. So this is also a series where, since we're returning a row as a series, all the indices are column names. So if we wanted to retrieve, let's say, the number of comments from row number 42, we would simply index it like this and obtain that value. Any questions about ilog? So one way to iterate over the rows in this data frame is using the function iter rows. This is similar to the enumerate function we had for lists. So it returns an index and the corresponding row from that data frame. So what we're doing in here is just for the first 5 rows, we're printing out the URL and the duration from the first 4 rows of the data frame. So in here, when we say row bracket URL, we'd be accessing it the same way as we do for the tedmain data frame itself, except we're doing it for that specific row that we got from iter rows, similar to enumerate. Any questions about this?
Yeah, I have a question. So are rows dictionaries?
Rows are Pandas series objects.
Okay. So you're accessing them like a dictionary, but is there any difference other than?
Yeah, accessing this so I see what you're saying. So for when we say row bracket URL, it seems like row is a dictionary of its own, right? So here, I think the only difference is with series objects, you can also do some additional manipulations like sorting or performing operations based on index, which you couldn't do in a dictionary.
Mhm.
I think series is built on top of Python dictionary. So.
What was that? I didn't hear that.
I mean, I was just saying, yes, the Pandas series data objects are built on top of Python dictionaries. So I guess all the methods that you have for dictionaries in Python should be accessible for series as well.
So the next function is .loc. So this is .loc instead of doing .iloc. So this when we do tedmain.loc6, this is also returning the 6th row in here, and the index of that row also happens to be 6. So it might be confusing where the index and the row number are the same. So let's try resetting the index of this data frame to something else. So this here we're using the set index function to set the URL as the main index of the data frame. So when we do this and say .head5, we're looking at the first 5 rows in the resetted version of this data frame. So the URL column has now become the index. So if we wanted to call loc versus iloc on this data frame, if we say iloc 0, this would return the first row. But if we wanted to retrieve based on loc, we would have to use the index which we just set as the URL. So if we say .loc 0, it won't work for this. Because 0 isn't an element in the index of this data frame.
So the I in iloc stands for what? Integer?
I think index.
Index, okay, fine.
The ith row of the data frame. So loc is for retrieving based on the data frame index, and iloc is for retrieving the ith row. So the next part is D types. When we call data frame.d types, it shows us a list of all the columns and the corresponding data types for these. So for these right now, we can see object. That's because it's being stored as some of these are weird. They're not integers, or even strings are being reflected as objects in here. So we would have to take care of that during pre-processing. Another handy function here for describing numerical columns is calling .describe on this. So for numeric columns, this gives you the total number of values, the mean and standard deviation, minimum and maximum values, and the 25th, 50th, and 75th percentile values. Any questions so far?
Why do they have count as being a floating number and not an integer?
I think this just has to do with the option that's currently set in the Pandas library. We can use the pd.setOption function to change that format.
Okay.
Okay, so another useful function here for displaying column-wise statistics is .value counts. So here when we say tedmain number of speakers, we're selecting that particular column, and when we call the value counts function, it tells us, so this is telling us that there are almost 2.5k rows with only 1 speaker, 49 rows with 2 speakers, and so on. So I've done the same thing here for the event column. We have 84 rows coming for TED Talks coming from TED 2014, 83 from 2009, and so on. So the next part is selecting specific rows or columns from this data frame. So if we want to select, let's say, only the main speaker and the speaker occupation, we would define this as a list and use this list as an index inside a square bracket to restrict the data frame to only these 2 columns. So this would also work if we do this in line, which means if we just say deadmean, and instead of having it defined as a separate variable, we just define the two columns in here.
Any questions at this point, just out of, to make people know that they're still alive? Okay, keep going.
Yep, so this is the database equivalent of selecting column 1, column 2, column 3 from this table. And then the next type of query we have is selecting, so that was for limiting columns. Now this is for limiting rows. So here we have, let's say we want to restrict our data set to only those rows which have the number of views more than this value. So we would say, we would select the deadmean views column, check whether it's greater than this value. So when we do this comparison, internally what it does is it maps every value within this column and does that computation for it. And so this map will be a series of true and false. Let's take a look at map. Yep. So map is a series returning true and false based on whether that comparison returned true or false. And when we index the data frame using this variable, it filters it down only to those rows which had a value of true. So that's for selecting rows. And so instead of doing this, if we want to select rows based on a bit more of a complicated criteria, this is where Lambda functions come in. So if, for example, if we want to select only those TED Talks which are coming from TEDx events, we would say choose this column and apply this particular function to that column. So this is where we're defining a function that takes in an argument string and it returns whether TEDx is present in that string.
That's a Boolean function.
Yep, yep. So this returns a Pandas series of, again, true or false. And when we index the data frame using this series, this is the same text pasted from the cell above. So if we index it using this series, again, it returns only those rows with TEDx in the event name. So this is equivalent to defining an is TEDx function externally and then doing TEDmain event.apply the name of that function. So if we use Lambda functions, that gets rid of the need to have this formal external function definition, since we aren't going to be using it anywhere else.
Okay, any questions about that? Or any of these other manipulations? Okay, get going.
There's this just other one handy function, sort values, where you can specify which columns or the order of columns that you want it to be sorted by. So here, let's say we want to do duration and event. And we can additionally specify whether we want it increasing or decreasing. So here it's sorted in decreasing order of duration, and within duration to sort ties, we've sorted by event also in decreasing order. We can also specify if we want one of these to be true and the other one to be false. So this gives ascending sorting priority to duration and descending sorting priority to event. So yep, let's get started with processing this data set. So the first thing to do is checking how many null values there are or how many nans there are. So this is null function. For every value in the data frame, it tells you whether that value is nan or not. And calling this dot sum on it basically does a column-wise sum and tells you how many nan values are present in every column.
So this is a way to look for missing values, is that right?
Yep.
And suddenly you see some, okay?
Yep, so 6 rows have the speaker occupation value as missing. So the way to deal with them can be either replacing these missing values or just dropping out the rows with missing values.
There's a question there about how you would check for non-nulls.
Checking for non-nulls. So you're saying you wanted to have not null instead of, so you want the true and false to be inverted.
Yeah, you can just add the tilde before the statement.
So adding the not operator before this would invert those values. Although for figuring out which ones you want to keep, there are better methods to do it. So if you decide to drop missing values, you can just call the drop NA function, or the fill NA function if you want to replace them with a specific value. So in this case, we're filling it with the string that says not specified. And it's showing us that, so when we filter based on checking whether that value for that column is the string not specified, it's giving us a length of 6, which means fill NA did its job. And for dropping rows with NA, you can specify whether you want rows with any one of those columns having a NaN value or having all of these as NaN value. And the in place variable tells us whether we want to manipulate the original data frame itself or return a manipulated copy of it. So in this case, when we call it with true, it's going to modify the data frame in place. And now the number of rows has changed from 2550 to 2544. So those 6 rows with ND speaker occupation got dropped.
We will be talking in here in the next couple of classes about data cleaning. And again, identifying missing values, imputing those values, or getting rid of the rows are kind of critical things. So this is a kind of an operation you're going to have to play with potentially, including, I believe, on the first assignment. I mean, on the next assignment.
Okay. Fahad will continue from here.
Any questions at this point?
Can you explain about in place in a bit more detail?
Oh, sure. So what's happening here, for example, is when we're doing fill NA with this particular value, this expression is returning a modified copy of the data frame TED main, and we're assigning it to temp. As opposed to if we call in place equal to true, we don't need to assign this to anything else because TED main itself got modified. Does that help?
Yeah, thanks.
Okay. And maybe you can respond to messages on it. Okay, so we're going to continue with pre-processing. So what we're going to do next is we're going to make sure that the relevant columns are in their right data structures. This is a common problem that you'll come across when you're working with real-world data sets, in that often the relevant columns that you want to work with are encoded as like the wrong data types. For instance, in this data frame we've been looking at, the ratings column is, as you can see, it's actually a JSON file or a dictionary, but it's encoded as a string. And similarly, there are other columns which have something to do with date, but they're also encoded in formats that may not be desirable. So there's film date here and there's published date here. So we'll be converting these into the right data structures, into the right data types that are more easily manipulatable. So what we're going to use to convert the string to a dictionary is use eval. This is very dangerous.
Right there, because I'm not understanding. The problem here is what? That the ratings, instead of being the number of ratings, is a word. What is the concern here?
So as you can see, the ratings, it looks like it's a dictionary, right? But it looks like it's an array of dictionaries. But if how do I add a cell? But if I'll try to access the first index of this data structure, it would actually give me, let me try this. it would just give me this because it's encoded as a string actually. When you were actually expecting the first element of the array. But when we'll run eval, and we do this, I guess I did not run eval. So let's try it now. So do you see the difference now? Now we're getting the actual element of the array as opposed, because previously it was wrongly encoded as a string. So we were getting, when we used the 0 index, we would only get the first character, but now it's rightfully encoded as an array, and so we're getting the first element of the array. Does that make sense? Does everyone follow?
If you don't, say something. Like, I don't understand and I'd like to hear it again.
Similarly, so just moving on, as
there's a question, would it be better to parse it as a JSON object and as a JSON into object instead of using eval?
absolutely. In fact, I would encourage that. I would encourage not using eval in most cases. We've used it here, but yes, there is a library that you can import. It's called just JSON, and I think there's a function that goes by loads, which would convert any string if it's in fact a JSON into the right data structure. So that's a good question. Thank you for that.
Yeah, just to add on, for some data sets, you might not know what exactly is inside that column. Some of them might have dictionaries, some of them might have lists. In that case, if the quicker thing to do would be applying literal eval.
But as the general rule of thumb in programming in general, try to avoid eval because it's very dangerous. So just moving along. So as you can see, there are two columns within the same data frame that have dates in their names, but when you print them out, these aren't really human readable, and so we're not sure what they exactly mean. So to convert them into more human readable forms, or even like in forms that can be more easily manipulated, we'll use this function, this really handy function that comes with Pandas. It's called toDateTime. And we'll pass these columns, and you'll see that they would actually go from these long integers to the right, more human readable data structures, as you can see here. This is the 5th column from the left. There might be some lag in the streaming of my screen, but you'll see it eventually. And actually, when we'll manipulate it more, you'll see that it's actually now a date-time data object, and so it has its own functions and properties where you can access the individual years, date, and month. And it's not just going from one type of string to another type of string, so it's much more handy. So in your assignments and in your project, presumably, you would definitely, if you're working with dates, especially, this function would really come in handy. And I would encourage like playing around with this toDateTime. Any questions?
Quick question. So can you explain about the unit equal to S part?
So I think what unit equals S is basically telling it is that the original value was seconds, so treat it as seconds. Charuta, correct me if I'm wrong. Right. So all it's telling the toDateTime function is that the original value was seconds, and I think there are other. So if you're ever confused about what these parameters mean, I would encourage using the question mark notation here, and this would give you a documentation right here. It says here. I don't see unit here right now. Where is it? Errors. So I can't see it right now, but basically to answer your question, it's basically telling the function that the original value of film date is in seconds, so treat it as such.
That makes sense. So it's helpful to know how the date time is actually being set in the data frame beforehand to convert it eventually.
Yeah.
Okay, thanks.
I have a question.
Mm-hmm.
How would date ever be encoded as a seconds value?
How would it ever? I mean, that's how we got
It's
the.
Unix time?
It's usually a date, a number of seconds after the epoch, okay, which maybe was a date in, I think, 1970.
They're
Oh,
referring
okay.
to timestamp.
Okay. Thank you.
One more question. So I've noticed that if you're storing dates via Excel, what happens is it tends to store dates as days, like number of days passed since 1st January 1900. So I'm guessing there could be inconsistencies with respect to the dates we get, correct? Is there something we do then?
So if you're saying that the original column has values which encode number of days instead of seconds since a particular threshold, then I think you can change just the value that you pass to this parameter unit. And you just, maybe there's an option where it allows you to pass D and it would sort of treat the conversion accordingly. Was that the question?
Yes, in a way it is. But the thing is, since Unix has a default time by which it's able to understand what a 0 second would be compared to the current second, Excel just has a weird way of formatting things. So I'm just worried about a data set which originated in Excel acting weirdly.
So I think Pandas also has a read Excel function.
Right.
Oh, okay. Okay. That makes things easier. Yeah.
In case you read Excel, it would just again give you a data frame in the right data structure, just as read CSV.
Sounds good.
Okay, in my personal experience, some of the quirkiness around Excel is more in the interface, but when you actually look at the values, they're actually encoded just as they are in CSV files. Just as a side note. But yeah, if you're working with Excel files and if you're worried about the conversion of the right data, you might be better off using read Excel, or is it read XLS, I think, or is it Excel? Yeah. Right.
Cool, thanks.
Oops. I'm not on my laptop, so I'm like struggling with the keyboard here. Is it frozen? I think it's gonna fix when I'm in the right place. Okay, so so we converted the dates, just moving along. If you want to manipulate values where you want to sort of swap values, this is how you do it. What this line, what it's doing is, first this bit within the lock, the first parameter that's in the lock is filtering out for rows where language equals 0, and then it's saying up for these rows that satisfy this constraint, update languages to 1. So that is what lock does. So lock is different from iLock, and it lets you update values as well. And this is how I think Pandas recommends updating values if there is need for it. So again, the first parameter of the lock function is giving a constraint on which you want to update the values, and the second parameter tells you like which column you're trying to update. And then what's on the right hand of the equal sign is the new value that any rows that satisfy the constraint would now take on. Any questions? The syntax here is a little overwhelming. Right? If you have any questions, feel free to ask them.
Why do we need to put languages twice?
So actually, we're using languages first to define the constraint or the filter, and the second is to specify which column we want to update. So for instance, we could have changed this to something else. Like for instance, I mean, I don't want to mess the data structure too much, but if we wanted to update comments based on a constraint that involves languages, then this is how we would do it. Does that make sense?
Yes.
Yes, thanks.
Would the same thing work if I close the brackets after double equal to 0 and open them again for comments, like 2D?
You're suggesting something like this.
Yeah. Does that work?
I think this would throw a warning. I used to do this a lot, and my code was riddled with warning every time I would run it. So this is the recommended way to do it. But yes, you can do it, but it's ill-advised.
Yeah.
I have a quick question. Is LLC is lock a function, or is it some way of indexing?
It's somewhere in between, I would say. It's kind
Okay.
of function, but it's yeah, it's definitely more than just like accessing an element at a particular index.
But it doesn't follow a function syntax, which is what's confusing.
Right. So for instance, you can remove the update, and this is what this is how it would behave, right? It's just saying, fetch me the comments of rows that satisfy this condition, and this is how it would work. And if you want to update it, I guess you'll add an equal sign. It's much more than just accessing things.
Okay.
A quick question about that. If you want to add another conditions, how do you do that? Do you add a comma?
Yeah. No, this is how I would do it. You can just put this in brackets, and you can say and you can say name comments equal whatever, and then you can change whatever. So this is how you would do it. You would sort of use Boolean ands or ors or whatever the right operations are to make the filtering conditions much more involved.
All right.
Okay. Any more questions? Okay, so moving along, staying consistent with this theme of data pre-processing and cleaning our data set, here we've found a weird quirk in this column, which encodes URLs to these TED Talks, and as you can see, all of them have this new line character at the end. So again, if you want to clean this up, how you would do it is you would use an apply function. We haven't covered apply function. So we already did. So this is sort of a good example for how you would be using apply functions in your assignments and projects. What this does, again, just for repetition, is this line of code would loop over all URL values, all values in the URL column, and it would replace this new line character with nothing. So it would just basically take it out. You could alternatively have used .strip as well, right? Yeah. Any questions? This is pretty straightforward.
For this line, does in place give me the same result?
Sorry, say it again.
For this specific line, if I do in place, apply on in place, will I get the same result?
Does apply allow in place? I don't think so. I don't think you can use in place with apply.
Okay.
But good question, yeah. So as you can see now that we print out the first URL, it does not have the new line character.
Out of curiosity, do you know how many of the original lines URLs had that return after it?
I mean, I can check. I don't know if I already.
I think it was all of them.
Maybe it was all of them, but
all of them. Then it's not really cleaning, okay? But
let's
have to go back and clean it.
Let me try. I don't know if I cleaned it ever. So so the 10th one has it. So it looks like all, if not most of them.
All of them have it. Okay.
All of them had it.
Okay, so that's dumb, but they're better off without it. Okay, fine.
But if it were the case that some of them had it and some of them did not, then this replace function would have been harmless, because it first finds this character, and if it's there, then it replaces it. So in either case, it would have worked. So now they're clean. Moving along. What we are trying to do, I guess, is right. And so we're trying to extract the speaker. We're trying to remove the speaker name from the title of the talk. And this is sort of how we would do it. This is basically saying look for the subset of the string which precedes a colon sign and replace it with nothing, basically. Does this make sense for how we did it? The problem here was that every title of the talk included was prefixed by the name of the speaker, and we wanted to clean it up because we have the name of the speaker separately as a separate column, so that was redundant, as you can see here. And this is what this is doing. This is sort of removing the speaker name out of the name of the talk. Any questions for how this is working? One interesting thing that you guys might have missed is here we're using axis equals 1 with the apply function. And what this does is this operation, so previously the way we'd been using apply was it would run on every value of the specified column. But when you use axis equals 1, this function remove speaker name is now going to run on every single row with all the columns of the data frame. And so, and we're doing this because in this function, we needed to access 2 separate columns of the same row. We're using name here and we're using main speaker here. So we could have only done this by having access to the entire row. And the way to do it is using axis equal 1 with apply. Any questions?
So what is the modulo in between the modulo s colon and row main speaker?
This is just a way to specify subsets of strings within the original string. Is that the question for like what is this operation doing?
Yeah.
This is basically just saying, give me the part of the subset of the string which comes before the colon sign here.
So modulo is for subset basically.
Yeah.
Okay, thanks.
Based on the
So that's only going to do it if the string is the same string as the main speaker name.
right.
String formatting.
Yeah. Yeah, so what's basically going to happen is this modulo s within the string is going to take on whatever this value is. And it's going to look for that in row name and it's going to replace it with nothing.
Now I'm confused.
So it's going to look, let me start over again. What it's going to do is it's going to look at this value and it's going to include this here. And it's going to see if this was like Fahad, for instance. If
I got it now, yeah.
And it's going to look for that pattern within row name and it's going to replace it with this.
Yeah. Okay.
And the strip, I think, would remove any trailing new lines or empty spaces.
It's kind of traditional, same as the traditional string formatting that we use even in C for printing when we say %f or %s.
Okay, thanks.
Any other questions? Any other questions regarding how we used the second axis equals 1 parameter? Okay, so moving along. So another cleaning step that we are going to do is, as you can see, for some of these transcripts, they have these words which don't really encode the content of what the speaker was saying, but maybe the reaction of the audiences in general. Like there is laughter in these parentheses, and then there's music ... in these parentheses. And because these are not really content of the talks, we're going to want to remove them. And the way we do it here is use regular expressions within the apply function. Because this is a much more complicated pattern, I'm not sure, unless you knew exactly what sounds or what words were going to appear within these parentheses, how would you have done it without regular expressions? So this is sort of how we did it. So I'm not going to go, because regular expressions, there are entire books just dedicated to regular expressions. So I'm not going to go into too much detail into how regular expressions work. But for just to touch on it, the way we do it is, this is basically saying, look for anything that is within the parentheses and replace it with space, basically. And it's going to run this on every value of transcript that we have. So what's going to happen is it's going to strip out words which might be a reaction of the audience, like laughter here. And so, and for regular expressions, of course, there's a library called RE, which again is very powerful. And without going too much into detail, this is how you would be using it for small data cleaning, data pre-processing steps. Does this make sense? Does anyone want me to like sort of go into further detail for how this regular expression is working? This sub function within the regular expression is basically, in quotes, substituting. So the first parameter is specifying the pattern we're looking for, and the second parameter is basically saying what to replace it with, and the third parameter is the original string on which to apply the transformation. Any questions? And so after the transformation, our data frame would look something like this without those audience reactions within the parentheses. So if no further questions, I'm going to move on to visualizations from data pre-processing.
Any questions? You've got about 9 minutes till class ends. So.
Okay, so I guess I can cover some of these visualizations, but I'll still, if anybody has any questions about data pre-processing, now would be a good time to ask.
Yeah. Now, presumably you can use a simpler set of these. Again, there's a lot of ways of doing everything. You can, of course, use the simpler way to do it until you learn more complicated ways. Right? So I imagine that, you know, if you're just new at Python, don't worry about learning it, you know, all the slickness, because you could get it done with simpler loops and simpler things, but keep going.
Okay, so just to start off with visualizations, we're going to just look at distributions that these different columns take on within our data frame. And so Pandas comes with this handy function called hist, which would plot histogram of each of the columns that are numerical. I don't think it does it for string variables. So for instance, a histogram for the transcript would not have made sense. So it only does it for numerical attributes, and you can see like what is the spread of their values in the plot below. Any questions for how this is working?
So presumably this argues that there is some what you call it, talk that has 6,000 comments, but almost none of them do.
Right. Yeah. So the comments distribution has a long tail. Most of them have like very small number of comments, but there are these outliers which have up to 6,000 columns, 6,000 comments. Yeah. So moving along. So that was histograms. So as you can see, some of the formatting got messed up here. Some of the labels are overlapping the axes labels here. And the way to clean it up, just as anything else in Python, is there is a relevant function for it that you need to know or need to be aware of. And the one relevant function that we need here is called type layout. Now this is part of matplotlib. This is not part of Pandas as such. Most of the plotting you'd be doing using Python, and in your assignments would be using matplotlib, maybe a little bit of Seaborn, which we'll cover as well. But if you're ever experiencing problems in terms of overlapping text from different labels and axes, the function we would recommend using is called type layout. And this is a matplotlib function, not a Pandas function again. And it would also strip out any white space on the border lines, so it would keep the layout nice and crisp and clean and using the most efficient usage of space. So as you can see now, everything is legible. All the comments, all the headers, all the titles are legible as compared to when we simply used hist without the type layout.
You would use type layout after you're done plotting everything?
Yeah, so that's a good question. Yeah, I should have mentioned that. You generally use a type layout after you've done all the drawing already. So you use it before you basically call plt.show if you're not using a Jupyter Notebook, or if you're trying to save your plots as, you know. So yeah, it's the function that precedes the final function of either saving your plot or showing the plot. So it comes right at the end after you're done doing all the drawing. That's a good question. Thank you for that.
Yep, thanks.
So moving along, right here we'll next just see how to make these simple plots, like multivariate plots, see how one variable is behaving with respect to another one. So we have the simple array which goes from 1 to 4, and let's say for this array we want to see what their square values would take on. So that's the second parameter here is the square of these x values, and plt.plot would simply plot the first parameter. It would take the first parameter as the x-axis and the second parameter as the y-axis, and the last parameter here is basically saying how to plot it. It's a formatting detail, you don't need to really go into it. And there you can read up on the documentation of matplotlib for all the different options you have. But for instance, if I remove this, I'll have to, let me just import this. If I just remove it, you would see it without the dots for the individual points. So you don't really need, but this is basically how it's working. The first parameter is the x-axis, the second parameter is the y-axis, and the following lines basically encode the legend and the labels for the different axes.
There's a question, why is there a semicolon at the end of something?
There doesn't need to be. I don't know. Why is there a semicolon, Charita? I don't know.
So when we don't specify a semicolon, it prints out the data type of whatever that command was supposed to do. Like, for example, if we're labeling the y-axis, it has the text that says power of x. If we just want to get rid of that and want only the image, we would add semicolons at the end, so as to not have the notebook printed out.
Right. So it's in a way suppressing anything that the function that you're calling returns. Is that fair to say?
Yeah.
Yeah. Because we're not interested in capturing whatever these functions return. So we just use a semicolon to suppress the return values. So our Python notebook remains clean. So now it's gone, as you can see. Good question. Moving along, these are basically more involved plots formatted in different ways. As I was saying, we were using -O before for formatting. Now we're using squares, as you can see in the green line here. So that's a simple change from O to S. And if you use -dot, you'll get a different formatting as well. And you can, of course, change colors as well. And these matplotlib functions take on all kinds of parameters that have to do with different formattings. And it's a very powerful library. And a lot of these plots end up being included in like highly cited papers. These are like really print quality publishable plots that you can get out of matplotlib. So it's very powerful in that sense. But for the assignments, I don't think you'd be needing most of those more heavy functions. Any questions for how these plots are working? Right, so.
Right, okay, so we're at go, you've got like 1 minute to go.
Right, so the only other thing that this is, I guess I should talk about is this is using grid, which basically gives you these gray lines in the background. It's more legible for where the axis values are and what these lines encode, basically.
Well, do you ever have to call plt.show explicitly in the notebook, or do you just do it here for just cause?
I'm sorry, there was some echo. I couldn't quite catch that question.
Oh, why did you call plt.show here and did it everywhere else?
So I think because we have matplotlib set up as inline, we did not really need this. Let me see if this works. Yeah, it works. So yeah, you're right. This is not needed here.
Okay, I was just wondering if something had changed that I didn't.
No, that's great. Yeah. If you don't have matplotlib set as inline, then you'll have to explicitly call show every time. But yeah, in this case, we have it set up as inline, and so we do not really need that. I guess I'll stop here before going to correlations, because that's a whole different topic in itself, and we'll sort of pick up from here for next time.
Right, so these guys will make an appearance a little later in the semester, probably about, if I think about 3 or 4 lectures from now, going into more of the machine learning kinds of things. And correlations is a good place to stop, because that's what we're going to talk about next class. Let's first start by thanking our students. So I don't know if you guys can clap, to what extent you can clap, make sure they hear it. Any other questions about that we want to ask them now? Where is the notebook available? Let me get that from you, and we'll try to put that on somewhere either on the web, probably on my web page. Okay.
It is
And
all
that
available there.
On the page.
This particular might be available already on your web page because of the previous offering. We used the same slide.
Okay, let's see if it's already there. That's good. Okay, and anyway, fair enough. Okay, if not, then I'll say thank you for doing this, and next class I will take over again, but you'll see these guys in a few lectures. Okay, okay. Anything else? If not, thanks a lot, and see you next class.
Bye.